Hey guys, how we doing? We are on the last section of the chapter.
Yep.
Finish it up, so that's good. Good thing.
Hopefully you've been watching your videos and trying things at home and
Yep.
doing what you're supposed to be doing.
Keeping up, yeah. So we're talking about polygons.
Yeah, so kind of an introductory lesson to polygons. We'll get more into this as the year goes on, but just a quick look. And since we were talking about, angles and segments, it's what happens when you put multiple angles and segments together. Well, we start to get polygons.
Yep.
And so a polygon is a multi-sided shape made up of segments only intersecting at their endpoints, called vertices. So here's that word vertex that we discussed earlier in the chapter. It comes back, and now we see it again on the polygons, and they're basically your corners of your polygon. Pretty straightforward. Just remember that all a polygon is multiple angles and segments put together.
Yeah, and you've seen these before.
Yeah, I mean the only one that may be a little bit different for you is the one there on the bottom left, the one that looks like an L, but it's still a polygon because it's a bunch of segments connected and has vertices. So
yeah. And they're only connected at their endpoints. They're
Yep.
not crossing somewhere or doing something weird. So that's still a polygon.
Yep.
Yeah.
Now there are exceptions like everything else, and here they're coming up here in a moment. And we consider these to not be polygons.
Oops,
Whoa.
sorry.
We consider these not to be polygons. How come, Mr. Scritch?
Part of them have curved lines, so we can't have curved lines. Again, the definition is segments intersecting. And so the sides of a polygon have to be straight segments. And so even though that Pac-Man looking one has some straight parts to it, but there's some curved parts to it too, and so it's not a polygon. And then that cylinder one is three-dimensional, first of all, but it does have curved pieces to it. And then that other one is actually two polygons put together, but if you can kind of think of those lines crossing each other in the middle there, kind of an X in the center, well, again, then the lines or the segments are hitting each other somewhere else besides the endpoints. They're hitting in the middle, and so that's not a polygon. Again, that's actually two triangles put together, and so two polygons put together. And so curved is really the
big one.
The one we see most.
Yeah.
So
now we've got two basic types of polygons. A polygon is convex if every diagonal lies inside the polygon, which means if you look at this first shape as it comes in here, these three here, if I was to start, and probably the easiest one to see it would be the pentagon, but if I was to start at the very tip of the pentagon up there at the very top and draw to any of those other corners, that line that I draw should either be on the edge of the shape or on the inside of the shape, and that makes it a convex polygon.
right, if you connect two vertices, it's either a side,
Yep.
or it lies inside the shape, inside the polygon.
And then a polygon is concave if any diagonal is on the exterior of the polygon. So as we look at some of these here, if you look at this one here, if I start from the top of the L part of that, on the inside part, and then I drew a diagonal all the way to the far right corner over there, that would be on the exterior of the polygon, so it wouldn't necessarily be it's not convex, it becomes concave because those diagonals are now on the outside of the shape, not on the edge or on the inside. If you look at the star, same thing. If I go from one point to another point, those diagonals are going to be on the outside of the shape, so that makes this one also concave.
And then, that's where I don't know you do the same thing. That's where I think of it, that if the polygon is caved in somewhere,
Right.
then that's concave. All those other ones, all vertices point out away from the center of the polygon, whereas in a concave one, it's caved in somewhere. And maybe that's the best one, I don't know.
Yeah, if you look at that, it's like somebody took a rectangle and then just pushed on the end of it and slid that other side out and brought the other part in. Well, it caved in a little bit. Like somebody sat on it. It caves in. And my advice really to you guys is know what concave looks like, and then everything else is convex.
Right.
I mean, that's basically, know one and you'll know the other just by default.
And again, technically on that last one, if you connected the two endpoints of that arrow on this outside, that diagonal, connecting those two vertices, that line would be on the outside of the shape, and so that's what makes it concave.
Yep.
So no convex, concave. Concave is the easier one to remember.
Yeah.
Convex is everything else.
Yep.
So. Okay, so we want you to write this table up.
Yep.
So basically pause it here and create this table in your notes. And if you know some of these names, and you got to be careful with some of them because some of them you think you know the name, but it's not that. And so the smallest polygon possible is a three-sided polygon. and then we go from there, 4 sides, 5 sides, and so on. And then it jumps a little bit because there's some special ones kind of at the end with 10 sides and 12 sides. They have special names, whereas I don't even know what an 11-sided shape is called. I'm sure it has a name, but it's just not very common, so we don't use it. And so we want you to fill in the name. When it says type of polygon, we mean the name of the polygon for all the rest of that table. And so we want you to fill in the right side of that table, and any of them you don't get, we'll try to figure out in class tomorrow. So pause here and work on that, on filling out that table.
But don't go away, because there's more to come.
There is, better even.
All right, so a regular polygon, and this is a really key idea here, guys.
It's critical that you understand that definition.
It's not difficult, but it is something that you get familiar with. But anytime we say a polygon or a regular polygon is a convex, so concave's out. Okay, so it's a convex polygon that is both equilateral and equiangular. And underneath there in the parentheses, all sides are congruent and all angles are congruent. So, square is the one you guys are most familiar with, or an equilateral triangle. Equilateral triangle is also equiangular. A square has 4 90-degree angles and 4 congruent sides. And then you have the octagon down there, same thing. All the angles are congruent and all the sides around it are congruent. And that's what makes it regular. And we're going to talk about that a lot later on in the year. And you just got to remember, when it says regular, that means everything is the same.
Right. So a regular triangle is an equilateral triangle. So a regular polygon is just that. All sides are equal, all angles are equal. And so it seems like kind of maybe a weird definition because of the word regular.
Right.
Makes it sound like it's just every day or whatever. But a regular polygon is a very specific shape.
Well, I think regular, when I think regular, it's bland. And so it's bland, it's boring.
It is the normal one
it doesn't have
do.
any weird things to it.
Right.
So
a stop sign is a regular polygon.
Yeah.
Yeah.
So
we see them most often.
Right.
When we think of a specific shape, like from the table that you were filling out, we normally think of the shape as being a regular polygon. So,
Yep.
All right. So the perimeter is the distance, and you guys have had perimeter for a long time. Perimeter is the distance around a polygon or around a shape, around a figure. And so it is the sum of all of its sides. So if you knew all the dimensions or all the side lengths of a particular polygon and just add them all up, that's called the perimeter. If you're fencing your yard, that's the perimeter. If you're putting the border around a pillow or whatever, that's the perimeter. If you're framing a picture, that's the perimeter of that shape, that picture. And it's always expressed in units or linear units, but it's always, feet or inches or miles or whatever it might be, millimeters. All right? So you're familiar with perimeter. You just need to remember that term, perimeter, distance around. Circumference is the same thing, it's just for a circle. And so we just don't call it perimeter for a circle, we call it circumference. And so the circumference is the distance around a circle, and because it's distance still, it's still just expressed in units. Okay? And then you're familiar with this one too, area. And so the area is the amount of surface covered by a figure, and it's expressed in square units now. So this is the different one. And so it might be square inches, or square feet, or square centimeters, or square miles, or whatever it might be. But typically when you're finding area, you're always multiplying 2 dimensions together. So like in a rectangle, you're multiplying length times width. So you're multiplying inches by inches, so you get square inches. And so it's always measured in square whatever you're in.
Unit happens to be.
Okay. So perimeter and circumference are basically the same thing, just on the shape, but you need to know that those are both distance around. Area is the area inside of a shape, covered by a shape. Okay. I don't know why that fraction's down there, but
It'll come in later.
so we're just going through the different shapes.
That's right.
Yeah.
So basically, guys, the formula for a square is that the perimeter is 4 times one of the side lengths, and then the area of a square is one of the side lengths squared. Now, this is new for a lot of you guys to see it as side squared. I don't think a lot of times you don't think of it as side squared. Most of you guys just fall back on it's a rectangle, so length times width,
yeah.
or base times height, whatever. But we
But
all
they're the same.
Yeah, we
Same
want to
square.
think of it as side squared, because in algebra, when we talk about squares, it's the number multiplied by itself, so it's side squared. So
Yep.
that's pretty basic for that one. Then we have a rectangle. Now the perimeter for a rectangle it's not 21 right there. It's 2 times the length, so the longer side, plus 2 times the width, which is usually the shorter side. It doesn't really matter. You could call one the length, one the width, as long as you take the 2 different measurements and then and then add them together. And then the area is the length times the width.
Yeah. And if you express that perimeter all the way, length plus width, That's where we get the two lengths and the two widths added together,
Right.
and then add those together. So.
And then for a triangle, for the perimeter of the triangle, guys, pretty basic. Add all three sides together. A plus B plus C gives you the perimeter of a triangle. And then the area is 1/2 the base times the height, which, you know, multiplying by half is not all that hard, but this one just kills students for some reason.
Yeah.
You know, I mean, it's just.
But you do also have to be careful of that height. That height has to be perpendicular to the
Yep.
base, not just one of the other sides. Can't be one of those B's or C's necessarily.
True.
Could be, but it doesn't have to be. And so you have to be careful of that height. It has to be a perpendicular height to that base.
Yep, it's got to be an altitude.
Right, right.
And then a circle, circumference of a circle. There's two different ways to do this depending on the information you're given. If you're given a diameter, it's just diameter times pi. Or if you're given radius, it's 2 times pi times the radius, or 2 times the radius times pi. We express circles kind of differently sometimes. We'll get into that as we do this, but you know, those are the two basic formulas for circumference of a circle. And then the area of a circle is just pi r squared. Now notice there's no d in there. So if they give you the diameter, you got to go back and find the radius, which is half the diameter, square that number, and then multiply it by pi. So just be careful when you do area of a circle.
And be careful between those two formulas. 2 times the radius times pi is very different than
Right.
squaring the radius times pi.
Right.
So be careful with that. Okay? And so there's going to be a few homework questions where you're using these formulas and just finding the perimeter and area of some basic shapes. So, all right, guys, that concludes the section and the chapter.
Yep.
Okay? So we'll be testing soon and moving on. So we'll see you guys in class.